this is for Year 10 Methods Pathways. We're going to look at exercise 10.5. We're going to look at a probability table question. Now, this isn't a standard probability table in that you don't just read the question and automatically fill in everything as is. You've got to do some calculations. Okay, so we know that there's a new disease. It's known to affect 2.5 to 5% of the population. A test for the disease has been developed, but it's not completely accurate. It correctly identifies the disease in affected patients 95% of the time, but also incorrectly identifies the disease in 7% of the uninfected population. So we've got a two-way table where you can either have the disease or not disease, and you can either be infected or not infected. Okay, so I'm going to draw a two-way table because this is always the start. I know the probability overall is 1. Okay. Now we know a new disease is known to affect 2.5% of the population. Okay, so 2.5% of the whole population is diseased. Now 2.5 as a percentage is 2.5 divided by 100, which is 0.025. So which means that the rest must add up to 1. So 0.975 should add up to 1. Now, to work out the rest of the table, we need to work out the other information given the question. So we know that tests for disease has been developed is known not to be completely accurate. It correctly identifies the disease in the infected patients 95% of the time. Okay, and that should be not identifies. So in the disease and identifies column, we know that 2.5% of the population is diseased. So 2.5% of the population is diseased. How do I work out diseased and infected? Okay, so we know that it correctly identifies the disease in 95% of the time in infected patients. So what you have to do is go 0.025, and you multiply it by 0.95 because 0.95 of the time it's correct. So you can go decimal 0.02375. Okay, 0.0. Oops, right here. 0.02375. So by definition, if it's correct 95% of the time, 5% of the time it incorrectly identifies the population that's not diseased. So you go 0.05 times 0.025. So to interpret that answer, that's 1.25 times 10 to the negative 3, which is 0.00125. 0.00125. What that E actually means, so if you go back to the question, what that E actually means is 1.25 times 10 to the negative 3, which means you're moving 3 decimal places, 1, 2, 3 decimal places there, so it becomes 0.00125. Okay, now we need to fill in the rest of the table. It also incorrectly identifies the disease in 7% of the uninfected population. So 7% of the uninfected population, okay? So it's saying that 7% of the population is identified as having the disease, even though they didn't have it. So it's over here. So they don't have the disease, but it's saying they're infected, okay? So you literally go 0.975, oops, 0.975 times 0.07. 7% is 0.07. So 0.06825. 0.06825. And finally, we know that must add up to 0.975, so you can subtract this. You can subtract this from this to get what that is, because we know the tables add up to each other, or the rows add up, the columns add up. So 0.975 minus 0.6825, and you get 0.2925. Okay, 0.2925, and I can add the rows together to get what the I and not I column is. So you can get 0.02375 plus 0.6825. 0.6825. Oh, that should be the 0. Apologies. 0.6825. Let's rewrite that. 0.6825. So let's go back here. That should be 0.90675. 0.90675. Oops. 0.90675. Let's quickly add up the totals. So we got 0.02375 plus 0.06825, 0.092, 0.092, and the not disease column, or not non-identifiers column, you go 0.00125 plus 0.90675, 0.908, okay. 908. Okay. Now, let's do the fun part. Conditional probability. Find the probability, given that they have the disease, they test positive. So given that they have test positive, what's the probability they have the disease? So once you've done the table, the rest is easy. Because we want, given they given that they test positive, so test positive means I. Okay, I identifies. So I means test positive, given that total. So the total is, so for part B, given test positive, that they have the disease. So D, given that they test positive. So the total would be the total of the test positive. The total of test positive 0.92. What's the probability out of that they have the disease? We can see that we're after this one, because this is where they have they tested positive and have the disease, so it's 0.02375. I'll work that out later. I'm just I want to get you to understand conditional probability. So you always look at the given part first, because that limits our sample space. So we're only looking at people that have tested positive. Given that, okay, so the probability that they test negative, so given that they test negative, they don't have the disease, so not disease. So probably that they test negative, I'll use the highlighter in this case. Test negative means this part. The total of test negative is 0.908, and they don't have the disease. Out of that, they don't have the disease, so it's, we can see it's this one, so it's 0.90675. So let's work this out on our CAS. So very quickly, we'll go 0.02375, and these are very fiddly. I mean, it's not the nice numbers that you're used to. That's fine. So it's 0.2. It says to how many decimal places? It says 2 decimal places. 0.26 here, And for the second one, you go 0.90675 divided by 0.908. So it's 0.99 to 3 decimal place, 0.999. Okay, 0.999. Oops. 0.999. Let's go back. 0.999 to 3 decimal places. Okay, so that's how you approach the problem. I mean, you're starting from your percentage in disease. You convert that to a decimal, and then you convert the percentage not disease to decimal. You know that adds up to 1, and then you work out the other probabilities based on the information given. So it's not necessarily a straightforward question, but, you know, as with anything, have a go at it.